Hello students, good morning. How are you? I hope everybody is doing well. Today we are going to study the Bohr's second postulate, which states that electron revolves around the nucleus only in those orbit for which the angular momentum is some integral multiple of h upon 2 pi. Electron revolves around the nucleus only in those orbit for which the angular momentum is some integral multiple of h upon 2 pi. So the question was that why should the angular momentum can have only those values that are integral multiple of h upon 2 pi. So understand this postulate and the answer of these questions, we should know the three things. First, de Broglie's hypothesis. Second, the standing waves. And the third, angular momentum. So first, we will see de Broglie's hypothesis. According to de Broglie's hypothesis, all material particles such as electron also have wave nature. All materials such as electrons also have wave nature. Yes, electron in its electrons in its circular orbit, electrons in circular orbits, yes, must be seen as a particle wave. So this was a hypothesis given by the de Broglie, and the better wavelengths matter wavelengths depends on mass and velocity. So this was the de Broglie's hypothesis. So here he said electrons are revolving around the nucleus and also as a wave natures. So here all the material particles such as electrons also have wave natures. Electron in its circular orbit must be seen as a particle wave. This is the particle wave. Matter wavelength depends on mass and the velocity. Yes, it means that lambda is equal to h upon p, and here p is equal to h upon mass into velocity. So lambda depends on the mass and the velocity. Yes. So here he assumed matter wave. He imagined the circumference. De Broglie imagined the circumference he imagined the circumference as a string. The circumference as a string. As a string, yes. And extending it in a straight line. This circumference imagined as a straight line. It is a string and it is in a straight line. So, we know that when a string is plucked, a vast number of wavelengths will be excited. But only those wavelengths will be survived which have nodes at the ends. The meaning is that this is the wave, this is the string fixed at both ends, and this is the wave. So, this wave only this wave will be survived. This is called the nodes, both is called. But if the wave is like this one, now this wave has not got nodes, yes, so this will die out. Only those wavelengths will be survived which has nodes at the both ends. Here only one node is yes, but here it is not yes. So this wave will be die out. So it means that in a string, standing waves are formed. This is called the standing wave, and when it is formed, the standing wave is formed when the total distance travelled by wave down the string and back is one wavelength, two wavelength, or any integral multiple of wavelength. So this is the wavelength 1 lambda, second, and the third. So he says that when the total distance travelled by wave down the string and back is one wavelength, two wavelength, or integral, means this is the distance. Distance between 2 points of a string, two numbers of wavelength. It means that the electron can exist in those orbit which had a complete set of n numbers, 1, 2 and 3, complete set of n numbers. But suppose the wave is like this one. Now nodes will not be here, and 1 lambda, 2 lambda, and there is what? Not complete lambda, yes. So here the lambda is completed, here it is not complete, yes, it is incomplete. So this is not a standing wave. It means that the electron can exist in those orbit which had a complete set of n number, complete set 1, 2, 3. Here is not complete set 1, 2 and some fraction is there. So set of n number of wavelength. This matter wavelength is depend on the mass and velocity. Mass and velocity, yes. So here electrons revolving around the nucleus, and this is the complete set of n numbers. So here let us say the lambda here. 1 lambda. Then second lambda. This is so 1, 2, 3, 4 lambda. So this is the complete set of lambda. Yes. So distance in string, we have studied this. L is what? Number of lambdas. Here is also distance is equal to the number of lambdas. Now what is the distance of the circle? The circumference. The circumference is equal to number of lambda. It may be 2 lambda, 3 lambda, 4 lambda, 5 lambda. So n lambda. We know the circumference of the circle is 2 pi r n lambda. Now lambda is equal to h upon p, and h upon mass. P is equal to momentum, mass into velocity. So this is about the standing waves. What about the momentum? Angular momentum. So this is the only definition is there, but we should feel it. Momentum, we should feel it. This is the chalk and this is the marker. It has got mass, it has got mass. If I throw it, chalk and marker, both will get the motions. So what is the momentum? The quantity of these motions. So its motions will be, its velocity motion will be greater than this one chalk, because it has got the more mass. Its mass is less than the mass of the marker. So what is the quantity of motions? So its quantity of motion is less than the markers. So that is the momentum. But here is what? Angular momentum. Angular momentum is what? Just like a fan. Fan is moving, some angle. So electron is also revolving. So this is what? Angular momentum. Yes. So with this formula we can write, yes, 2 pi r is equal to n. We replace the value of this one, h upon m vn in the sum radius. So we take m v n this side and n h 2 pi these sides, and this is what? Angular momentum. L is equal to nh upon 2 pi. And this was the explanations of the Bohr's second postulates, and this way we have proved. Yes. So thank you very much, students, for watching this video. Have a good day.